Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are going to take a look at the solstice. Of course, it is June, it is the month of the solstice, and the solstice on the 21st is one of the things that happens to the entire world. Of course, here in the northern hemisphere, it's the summer solstice, so the sun will reach its highest position in the sky. And we can take a look at that here. The sun was lower in the sky just a few months ago. It's coming up to its highest position now and falling back down as we move in towards winter. It is the opposite in the southern hemisphere. It is the winter solstice. The sun will be at its lowest point in the sky. But it is still the solstice. Even at the equator, it is the solstice. But of course, it is a little bit different if you are very close to the equator. We're going to take a look at the solstice from the sun and from the moon. I think the reason why we would look at it from the sun is pretty obvious. We're going to be looking at how the pole points towards the sun for the summer solstice if we're taking a look at the Earth. It looks like we're on the wrong side of the sun for the Earth to be in the sky, as it were. From the sun's perspective, the Earth will be in the sky. There we go. There's the Earth up for the sun. So here we will take a closer look at the Earth. The Earth in Stellarium is an image, and of course it's not perfect. There are clouds, it can be difficult to make out certain details. But taking a look at even this view here, we can see South America pointing off down in this direction, and there's North America up towards the top. If we move through time, we will see the Earth rotating, and if we move back, we'll see it turning the other way. For me, the part of the Earth that I am most familiar with is Europe, so we'll turn back until Europe is facing towards the sun, just like this. So we can see here, certainly Europe, but we can also see the Arctic ice cap. And up there is the pole. We can't see Antarctica really at all. Antarctica is just south of South Africa there, the bottom portion of the Earth. But we can't see it. It is in nighttime. The sun isn't shining on it. Whereas looking at the Arctic here, it is in daytime. The sun is shining on it. And if we go through a whole day, we'll move through time until Europe is facing us yet again. Here we go. The Arctic stays visible. The Antarctic stays invisible. So we can see here that it is summertime. The northern hemisphere is tilted towards the sun, and if you are high enough on the northern hemisphere, the sun will stay up the entire time. If you are in the southern hemisphere, it's tilted away from the sun, and the South Pole is completely pointed away from the sun. So the tilt here is pretty extreme. You might just about be able to catch part of Australia down there, but if we take a look up here, we're still seeing Europe even up as far as Norway and Sweden. They're barely going to go into the nighttime side of the Earth as we turn through these dates. And we have taken a look on this channel before at how the atmosphere distorts light, how the atmosphere will refract the sun so that it appears above the horizon when it should be under the horizon. That's going to allow sunlight to creep even further around this edge than we can actually see. Of course, that's true at the opposite edge as well, but Antarctica is pretty far down and of course pretty big as well. So we can see here that it is summertime and that on the date of the solstice, of course, it's true for a few dates around the solstice, but certainly on the date of the solstice, the South Pole is pretty much pointing towards the sun the entire time. In fact, I think we can see it here. This little boundary is between the Arctic ice cap and the island of Greenland, the very large island of Greenland. So that's more obvious here. But as the Earth turns around, as the nighttime side of the Earth turns into nighttime, here we go. There, I hope you can see it, is that line where Greenland joins onto the Arctic ice sheet. So that portion of the Earth is being shone on by the sun. the entire time. It doesn't actually go into nighttime because of the tilt of the Earth. And of course, the opposite would be true from the opposite side of the planet, but we would be looking at darkness and looking away from the sun, so it would be difficult for us to see from here. But that is part of the reason why we are going to the moon. The moon is going to be full on the 29th of June, and so its full moon, the full moon, is fairly close to the solstice. It's close enough at least. But here we are on the solstice. The moon is not quite going to be a quarter. If we take a look at the Earth here, it's illuminated 58.8%. If we go back a day, it goes to 60. If we go forward a day, it goes to, well, 58. So it looks like we're close enough to around seeing a quarter Earth here. And again, it's not going to be very brightly lit up, so it's going to be a little difficult to see. We'll have to turn the Earth around until we're looking at a view we're familiar with. It looks like we're upside down, and we are a little bit in the moon's southern hemisphere. So just to make things easier for me to see, to make things more recognizable for myself, we'll go into the northern hemisphere. That should put things, yes, closer to the right way up. So there is North America, there's Florida, we can see Central America there, and we can see that the angle of the terminator, the line of nighttime, this line of darkness here, it is going across the Earth at an angle. The Arctic up here, that white patch, is staying pointing towards the sun. The axis of the Earth's rotation isn't lining up with the line of the terminator, the axis between daytime and nighttime. So that is again showing how the Earth is tilted during the summer solstice, but perhaps this will be a good example. So we can see here Europe, there's Spain, and we can see that this part of Europe, Western Europe, is very much in daytime. We can see Africa there, the west of Africa is very much in daytime. The date line, the Greenwich Prime Meridian, one of the lines of longitude that's used to break up time zones, it runs through Greenwich in London, so it runs through England, it goes all the way up to the pole, and it comes down through Africa and out the other side. It doesn't go through Spain there, it goes through France and down into Africa. So that line of meridian, the prime meridian, is running parallel to the Earth's axis of rotation. Well, it is a curved line, it is on a sphere, but if we look at the kind of front part of the sphere here, it doesn't line up with the line of the terminator. The line between daytime and nighttime is at a very different angle. It's daytime here, it's nearly sunset. Looking at this, it's nearly sunset for Europe, and it is daytime, sunrise really for a lot of South America, but the sun is shining on South America and the sun is shining on Europe at the same time. More importantly, the sun is shining on this part of Europe at the prime meridian, but following that prime meridian down, we move into darkness. Down in South Africa, it's already nighttime, which may seem a little bit counterintuitive if we look at a map of the Earth. So we'll bring back the Earth here. There we go. We can see there's England and France, and we can see that the prime meridian would come down through West Africa pretty close to the coast of Africa, whereas we could see that the line of the shadow, the line of the terminator, was coming across Western Europe, across West Africa, and down towards South America. Parts of South America were turning towards nighttime. So the Earth is really quite tilted when we are experiencing the solstice, and that tilt, it doesn't just mean that the North Pole is pointing towards the sun and the South Pole is pointing away. It does mean that, but that also means the line of where nighttime meets daytime, the terminator, it's still the same way. The terminator is still the division between the half of the Earth facing the sun and the half of the Earth facing away. So when the Earth is tilted, the line of the Earth's axis, well, the line of the Earth's axis would be vertical in this. The line of the Earth's axis doesn't line up with the line between daytime and nighttime. It would, or it would at least more closely align on the equinox, but we'll need to wait until September before we take a look at that. We'll return to our default location here in Ireland and come back to looking at the solstice, and we'll take a closer look at the moon. We'll see how close to half it is. Pretty close to half, and that's what I was hoping for. The quarter moon puts us in a position where from the moon we're looking at the Earth's terminator, and that's the view we got. Thankfully the moon was in the right position to provide it on the date of the solstice, which doesn't always happen. But I hope that you enjoyed that view. If you did, please do like this video, and if you enjoy this kind of content, then please subscribe to this YouTube channel. If you would like to read this information, you can do so on my website, queebeanscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.